All right, good morning, everybody. We're here for round two. Going to be calculating the volume of another irregular shape here, uh, this time in the shape of sort of a hot tub. This is pretty different, though, in that it is circular, and so we need to know some of the terminology around circles. We need to know the area formula for a circle and the volume formula for a cylinder, which are very related. So if we take a quick look at this diagram, we see we really have sort of two cylinders nested on top of each other. We've got sort of this first cylinder here, which comes, on the top. It's shallower, but it's also much wider. And then we have this sort of inner cylinder that comes down below. I want to point out, maybe I'll do that in a different color. I want to point out something about the dimensioning here, just so we're all clear. This 10 feet number is the diameter of the smaller cylinder, and the 14 feet here really is this whole distance across from here to here. That's sort of our other diameter, this 14 feet. Now, when we're finding the area of a circle, I'm going to draw one down here. And if we have a point in its center and we draw a line out to its circumference, we call that r, the radius, and that's only half of the diameter. And you'll notice that all the area formulas use this r thing, not d. And so when we're finding the area of a circle, we're just going to take the number pi, which we'll talk about in a second, and we're going to multiply that by the radius squared. Now, the way that I remember this personally, and to give you maybe a bit of a geometric intuition for what this is kind of saying, let's think about literally what does r squared mean? R squared means r times r multiplied by itself, and you can literally think of it as sort of a square sitting out here that r makes with itself. Now, in order to sort of fully encapsulate this circle, we would need, for sure, well, I should say, if we had four r's, if we had four full boxes, we would for sure capture the entire area of this circle, right? We kind of trapped this circle inside of this box that is 4r squared. But we don't need 4r squared, right? We've captured too much area. We really would like to shave off these corners. And so the area that we're talking about is just the circle. And so in reality, we don't need to multiply r by 4. We need to multiply it by something that's a little less than 4. And that number just so happens to be pi, 3.14-ish. Um, so that's kind of just a geometric interpretation. And the only difference for the volume, for volume, the volume formula is going to be extremely similar. It's going to start out exactly the same way, pi r squared, because we really still have this circle. It's just that we are now sort of pushing it down through another dimension. And so if we want to get technical, it has to be perpendicular and all that. We can't have a slanting cylinder. But the perpendicular distance between the two circular faces, we call the height. And you can think of that as the circle being pushed through the third dimension, and all we really do is multiply it by that number, and then we've got our volume. So Back to the original problem, there's one last issue we got to talk about before we actually solve this. Once we talk about that, the solving shouldn't take actually that long. And you may have seen it already, but it's this inches thing here. We have to make sure that all of our units are the same and the other dimensions that we're given are in feet. Now, you could convert everything over to inches, but why convert three numbers when you could just convert one? So to convert the 21 inches number into feet, we really just have to divide by 12. There are 12 inches in a foot, so we can multiply it, really by that rate of 12 inches in 1 foot. That's where the divide by 12 comes in. And so we get 21 over 12, which is 1.75 feet. Now I'm going to split this up into two chunks again, right? But ultimately, the total volume is just going to be this first volume, which I'm going to do the top one, plus the second one. There's no like overlap or anything. We're kind of cleanly cutting this whole object into two pieces. So for the first volume, we've got the sort of the bigger diameter here. Now the diameter is 14 feet. The radius is only going to be half of that, or 7 feet. And it's being pushed through a height of that 1.75 number that we calculated above. So let's go. We got the volume here. It's going to be pi times the radius squared times the height, which ends up being 85.75 pi. Now, we always write pi at the end once we've kind of calculated a number like that. I like to leave the actual multiplication of 3.14 till the very end once I've sort of calculated everything that I can other than pi. That's just a mathematics practice type thing. In a math class, typically they're going to want you to leave your answers as exact, multiples of pi. They typically don't even really want you to find the decimal approximation. They would prefer an answer of 85.75 pi to the 260 whatever decimal equivalent that would be. Now let's go on to the second one, which is extremely similar. It's just a little bit smaller, a little bit deeper though. This diameter is only 10 feet, so half of that is going to be 5 feet. Its depth is 2.25 feet. It's a little hard to see on that diagram, but it's kind of in the back there. It's measuring the depth from this upper lip down to the lower part of this lower cylinder. So V2 is going to be pi times 5 squared times 2.25. These parentheses aren't really necessary. It's just the way that I typically write it, just to keep things real clear. And 5 squared is 25 times 2.2 is 56.25 pi. So there we basically got it. We're almost done. We got our two pieces here. Our volume total is just adding those up. So the total volume is 142 pi. Now, in your math class, you might just want to leave it like that. However, if you're really trying to do something with these numbers, if you're actually trying to treat this pool, you probably want to interpret it as an actual value that we're more used to and multiply that by pi. And so the decimal approximation of that is about 446.11, and we should definitely include our units here of cubic feet. So really that is probably the more useful technical answer, but 142 pi